Hello, students. Uh, Today we are going to see a new chapter which is known as functions here, and you can see that the this is the table of content. Before going into the chapter, we will see the table of content. So you are having 16 chapters. Okay, 16 chapters of theory and 10 practical exercises. The first chapter is function. This comes under the unit problem solving techniques. The first four chapters comes under the unit 1, problem solving techniques. Okay, so in this function chapter we'll be learning about uh, yes, we'll be learning about function specification, parameters, interface versus implementation, pure function and impure function, and side effects of using the impure function. So these are all the things that we are going to see in this chapter. So the most important criteria in writing and evaluating the algorithm is the time it takes to complete a task. So if you are writing an algorithm, so, or even if you are writing a program, or if you are if you are developing a software, then the first thing that the first factor that you has to be considered is the time. Okay, so you must consider the time factor, which means that your software or your program or your algorithm execute should get executed, or the work should be done in precise amount of time. So your program or algorithm should not take so much of time in completing a small task. Okay, so that's why you to have a meaningful uh, comparison on the algorithm, the duration of the computation time must be independent of the programming language compiler and the computer used. Okay, so this timing that takes to complete uh, complete a task should be independent of computer used or the compiler used, or even it should be programming language used. Okay, so even if you implement the same concept with different programming language, the compile time should be lower. So that's what they're trying to say here. So as you are aware of, programs are expressed using statements of programming language. uh, if a bulk of statements to be represented for many number of times, then subroutines are used to finish a task. So if a very number of statement, okay, and many number of statements has to be executed repeatedly, then you can use this subroutine. Okay, subroutine is nothing but a small part of program. We'll see that. So subroutine are the basic building blocks of computer program. Subroutines are small sections of code that are used to perform a particular task. It can be used repeatedly. Okay, so subroutine is a small set of instruction or a small subdivision of a main program, so that it will be uh, executed more number of times. Okay, and and you can see that it is meant for doing a particular task. So it is used to do a simple task. So that's what it's said here. So in programming language, these subroutines are called as functions. So functions and the subroutines are the same. Okay, So in programming language will say that functions, but in algorithm we'll be saying that as a subroutine. So function with respect to programming language. So uh, what are the factors that are affecting the performance of a function with respect to programming language? So we'll see that one by one. So the function is a unit of code that is often defined within a greater code structure, especially a function contains a set of codes that works on many kind of input like variance expression and produces a concrete output. So function is as you know, function is a small set of code. So this function can work. Okay, so the function will be getting a small input from the user or from other part of the program. So small data will be inserted into the function. Okay, if that function is uh, is not clear. Okay, so if the function is not clear or the input that is given to the function is not clear, then it will affect the output of the function. Okay, so that's what they're saying here. So here you have to specify the input. Okay, so that's what it's function specification. Okay, so let us consider an example. A is equal to 24 and the expression, it has an expression in it, but 24 is isn't a expression, rather it is a function definition defined bind value to the name. In case the value 24 has been bound to a name A, definition is not an expression. Not a, at the same time, expression are also treated as a definition or distinct syntactic block. Okay, definition can be expressed nested inside them and vice versa. Okay, so here you have to specify the type of the data that you are using. Okay, say for example a is equal to 24. So in that this is not uh, exactly a definition, since the type of the value is not mentioned. Okay, so it may be an integer type, it may be a uh, floating type variable, so the type is not mentioned here. So you can see that mm, uh, it is not a valid expression here. So that's what they're trying to say here. So next is parameter. Parameters is the value. Parameters are the variable in the function definition, and the arguments are the value which are passed to the function definition. So mostly all these things are the same. Okay, parameters, arguments, uh, both are the same. So they provide variable values to the function. Okay, so as I said earlier, function is a small set of program that will get uh, input from the main program or from the user. So this the value which is given as an input to the function, which is known as parameters or arguments. Okay, so there are two types of parameters here. So parameters with the type and parameters without type. Okay, so we'll see the example here. So they have given an example here. So here they are going to create a function. So requires b greater than or equal to 0. So return a to the power to the power of b. Okay, let's uh, rec power a comma b. If a is equal to a is equal to b, sorry, b is equal to 0, then 1, else a into power of a power b minus 1. Okay, so here they are finding the power of this is a small algorithm steps. Okay, this is not a program programming language program. So this is a small algorithm steps. Okay, so here the first line says that uh, you have to get the input for b. Okay, the value, the variable b should be greater than or equal to 0, and you can see that you in turn you have to return the power value. Okay, in turn you have to return the value a to the power b. So here you can see that uh, let power a comma b is equal to, if b is equal to 0, then the answer is 1. Okay, so anything power 0 is 1. So that's given here. So if b is equal to 0, then a to the power 0 will be the answer as 1. Okay, so if not, then you have to calculate the uh, expression a into power of a minus 1. Okay, a to the power b minus 1. Okay, so a into a power b minus 1. So this is the uh, this is the expression here. So here you can see that the above function, defines a definition variable. The above function definition variable b is the parameter, and the value which is passed to the variable b is the argument. Okay, so the preconditions is the required, and the post conditions are the return of the function. uh, Post condition of the function is given. Note, we have not mentioned the data type. Some programming language solve this type inference problem automatically, but some requires the type to be mentioned. So here you can see that they have explained everything clearly here. So the precondition, so before getting into the function, we required some data. So that data is known as precondition. So after finishing the execution of the function, it will return something. Okay, it will return the output of the function is a return statement. So that is known as post condition. So here we have to note one thing: the data type of the two variable a and b is not given here. Okay, or the output which is received from the function is not given here. So that what is to be noted here. So some programming language have this feature automatically. Okay, so based on the value which is given to this variable, the compiler or the programming language itself will convert that number as a data type, and it will find the data type automatically. Okay, so no need to provide the data type. But even though some of the programming language has its own disadvantages, so you have to give the data type manually. So the above function definition, if the expression can return 1 in the then branch, so there is a then branch here. So by the type rule, the entire if expression has a type int. Okay, since if expression has the type int, the function return type also be int. So b is compared to 0 if compared to 0 with the equality operation. So b is also a type of int since a is multiplied with another expression using the operator, using the star multiplication operator, which is an arithmetic operator. Okay, so a must be an int. Okay, so if you are multiplying two uh, two integer value. Okay, so here you can see that uh, they are multiplying two values. Okay, with the operator, multiplication operator. Okay, so the return value is 0. So here here it takes some time. Okay, so since the data type is not provided for three of the variables a, b, and the uh, output variable. Okay, so the answer expression of the expression a into a power b minus 1. So this expression uh, is not given a type. Okay, or the output which is evaluated from this expression is not given. So that's what parameter without type. Now we'll see the next type, parameter with the type. So here you can see that this parameter with the type will explain you that the same function or the same set of algorithm, but here you can see that the values are given a data type. So a is equal to int and the b is an int, and the function which is the result of this function will be an integer. Okay, so this is a function with time. So here you can see that the execution time of the both this function will be different. So the parameter, the function with the type, or the parameters with the type will get even more time. Okay, time to execute, but the parameters without type, uh, so parameters with the type will take less amount of time to execute. Parameters without type will take uh, without type will get even more time. Okay, so the compiler should convert the given value into uh, its required type, and then it will evaluate. So it takes some time to evaluate. So this time will be reflecting in this um, reflecting in the output. Okay, so this output uh, uh, will be received, so will be received based on the factor. Okay, uh, so this is mm, so this is the factor that are affecting the output of a function. Okay, so if you are not giving the exact data type of a variable which are used in the function, then the function will be delaying the execution of the instruction. So next thing is the function definition. So a function defined which calls itself is called recursive function. So this is also a type of function. The function will be calling itself. Okay, so that is known as recursive function. So we have seen in the last year syllabus itself. Okay, so here they have given an example. So the function that will be calling itself. Okay, so here you can see that odd is a function and even is a function, so it will be called by itself. Okay, so that is known as uh, function that calls itself. So here you can see that another all function are statically defined. There is no dynamic function defined. Okay, so the function is fixed. Okay, you cannot able to change the function at the runtime. Okay, so that's what it's given here. All the functions should be static, should be fixed. So the next thing you have to see here is interface and implementation. So an interface is a set of action uh, that an object can do. For example, when you press a light switch, the light goes on. You may not have a you may not have cared about how it splashes the light. In object-oriented programming language, the interface is the description of all the function. So that that a class must have in order to be a new interface. For example, uh, uh, anything that acts like a light, okay, acts like a light should have the function definition light turn on and turn off. So any function that should that is acting like a light should have two functions, which is turn on function and a turn off function. So the purpose of interface is to allow the computer to enforce the property of a class of type T. We must have the function called x, y, z. Okay. So this interface is set of rules. Okay. So interface is a set of rules that has to be followed when you are creating uh, a function, okay, or a class. So here you can see that uh, uh, there is a function which is known as they are creating an interface, so that is likely to be having the functions of light. Okay, so if you are using this light as a function, then you need two important function which is known as uh, light on, turn on the light, okay, and the turn off the light. Okay, so these are all the two important functions that has to be used when you are using the light property in your function. Okay, so likewise there are so many examples that can be uh, in your day-to-day life. Say for example, you are using a function. Okay, so when you are using this function, you have to create another function in such a way that that function should get the input from the user and store the value inside the function, and another function should be created so that the output of the function should be displayed to the user, or in the display to the stored inside a file. Okay, so this is known as getter function or setter function. Okay, so these are all the basic functions. So the class next thing is the class definition combines the external interface with the implementation. Okay, so here comes the next part. Here implementation means developing the rule. Okay, so interface means rules. So so if you are implementing, or if you are creating the idea of interface, then you'll be needing some programming language to write the interface. So that's what is given here. And difference between interface and the implementation. Interface just defines what an object can do but won't actually do it. But implementation carries out the instruction defined in the uh, interface. Okay, so this is the difference between interface and implementation. Interface will just give the rules, okay, but in implementation will actually do the work, okay. So next is characteristics of interface. So the class template specifies the interface to enable an object to uh, create and enable enable an object to be created and operated properly. So there will be a template. So when you are creating an interface, then there will be a template for it, okay. So in implementation you will be just you will be just developing that template, okay. So that's what it's given here. The object's attributes and behavior is controlled by sending function to the object. So here the object has some attributes and behavior. The object will be so based on the uh, based on that, the object will send some data or receive some data. Say for example, let us take an example of car. So here they are given an example as car here. So here engine get speed. So required speed yes. Uh, uh, no means full fuel. Okay. So requires so if the engine wants speed, then it will require fuel. Okay. If it's not if it's not required speed, then it will not require that much fuel. Okay. So this kind of data is used here in this uh, implementation, okay. So there are two things here, uh, pure function and the impure function. So pure functions are function which gives exact result when the same arguments are passed. So here you can see that uh, there will be two different function, but when you give input to uh, when you give input the same inputs to the two different function, the output will be the same, okay. So output will be the same, and there will not be that much value changes, okay. So that kind of function is known as pure function. So for example, the mathematical function sine 0 always result 0. This means that every time you call the function the same with the same argument, you will get always the same result. So the function can be pure function, provided it should have an external variable which will be altered in the altering the behavior of the variable, okay. So here you can see that based on the value that is given to the pure function, the value will be the same, okay. The output value will be the same. uh, so this is known as pure function. Impure function, here they are given some examples here. We see that. So next is impure function. So impure function, the variable used inside the function may cause a side effects through the function, so which is not passed with an argument. So in such case, the function is called impure function. So uh, it will create a side effect when you are using an impure function. Okay, so the output will not be the same. So if you are providing an input to a function, it will provide a separate answer. If you are providing the same function with the same value, but it will in a certain condition, then it will provide a different output, okay. So this is known as side effect. So in impure function it creates side effects, okay. uh, that's what is given here. And here you can see that uh, they have given some random number. So this is a function which provides a random number, okay. So this random number will give you give you random numbers based on the value that you give. Okay, so you need two random numbers, and you are giving input to the random number function too, but you'll be getting different values for the same input. Okay, so this is what it's trying to say here. So the value that is involved, the value that we give to this random function will affect the output. Okay, so will affect the output. So that's why it's known as impure function. It creates a side effect to the output of the function. Okay, so this is the difference between pure function and impure function.